There's a question about this example, so I just wanted to go through the example here and see if we can make it make sense. So it says sketch a graph of one period of the function y equals 0.5 tangent of pi over 2x. So they're showing that we break this down into a couple parts. We have this leading coefficient that's going to be RA. That's going to affect the, I wouldn't say amplitude so much, but that does affect how it's stretched or compressed. Then this pi over 2 is our B, and that's going to affect our period. So the A being 0.5 means it's going to be compressed because it's less than 1. If it's bigger than 1, it's going to be stretched. And then the B equals pi over 2, again, it's going to affect our period. So the normal period for a tangent function would normally go from like negative pi over 2 to pi over 2, which is a distance of pi. So we take that pi and we divide that by pi over 2. So we get pi times 2 over pi, and those cancel, leaves us the 2. So that tells us that one full period is going to be 2. Now there's no horizontal shifting, which is why we get this graph here going from, instead of going from negative pi over 2 to pi over 2, it's the center point's not going to change. It's still going to be right here at the origin because there's no horizontal shifting. So that means we're going to go 1 in the positive direction, 1 in the negative direction, which is why it goes from negative 1 to 1. Now the question was, what is f of 0.05, which is this value here? Now I want to point out a couple things. If we were looking at, instead of it going from negative pi over 2 to pi over 2, we have an asymptote here, we have an asymptote here, and it come up and do something like this. Now, an important value to know, this is one that we should memorize for the class, is that halfway between 0 and pi over 2 is pi over 4, and halfway between 0 and negative pi over 2 is negative pi over 4. Tangent of pi over 4 is 1, and tangent of negative pi over 4 is negative 1. So what they're doing here is they're saying, okay, we have it going from negative 1 to 1 for one period of this new function, and the halfway between 0 and 1 is the 0.5, and between 0 and negative 1 is negative 0.5. So that's why they chose these values, because those are the values that should represent 1. But with this leading coefficient of 0.5, let me just go through what they've done here. So they're saying, now this is a coincidence, this 0.5 and this 0.5, purely a coincidence. So don't think that there's some, like if there's a 0.7 to be a 0.7 there. Not the case at all. So this 0.5 here was chosen because it's that midway point. So if we look at tangent of 0.5 pi over 2, well, that's like saying tangent of 1/2 pi over 2, which is 1/2 times pi over 2, which is pi over 4. And I probably should have kind of put that together. So this is really saying tangent of pi over 4, which is 1. So that's what they have there. And then the 0.5 times 1 is 0.5. So this 0.5 just references where on the graph that would be. That's going to be here instead of at 1, where it would normally be, but the 0.5 leading coefficient compresses it. So I hope that clarifies what this is asking for. And they're doing this to get some points to come up with how to plot it and to really express how it's been compressed. But I really want to stress as well, let me erase this up a little bit, this is not saying f times 0.5, that is the function evaluated at the value of 0.5. So this 0.5 is this 0.5 here. Again, it's unfortunate that they used a 0.5 as the leading coefficient and the 0.5 as the value to be substituted in. So, but that's how it is. Just want to clarify on some of these values. Hope that makes some sense.